kids, how you doing? This is Mr. Eric and my two assistants. This is Timothy and this is Eleanor, and they will be helping me today to explain to you ocean currents. So what we're going to do is two experiments. One about salinity, which means how much salt there is in the water, and the other one is about ocean temperatures and how those affect the deep ocean currents, and they mix up the water and how important that is to our oceans. You guys ready?
In this experiment, I'm going to have Timothy place a few drops on the right hand of a pan filled with water, and my other assistant, Eleanor, place blue drops on the left side by a pack of ice. We're going to see what happens to the actual flow of the water, the current of the water, as the temperature acts upon it. Just going to put in the ice.
Like right that. Can you do it? Okay, just put it to the side.
Okay.
Okay. Go ahead, Eleanor. 1, 2, 3, 4. Okay, take it away. Now you on this side. Keep going. 2, 3, 4. Okay, everyone put your stuff away. Now let's watch what happens.
So what do we see happening here? We see the blue dye, which is the cold water, because it's nearest the ice pack, is pushing against the red water, which is the warm water. And it's slowly pushing away. Why is this? Because cold water is more dense than warm water and therefore exerts more pressure. So it seems like the cold is actually pushing the red there and keeping it from moving, right? So let me just explain something, and then we're going to add some warm water to this whole system.
Water expands when it warms up. Heat energy makes its molecules move around more and take up more space. When water cools, it contracts and becomes denser.
Here I'm just going to add some warm water with that food coloring in it to make the whole process of mixing happen a lot faster. There's going to be a more defined warm layer and a more defined cold layer.
You look on the side, you can see that the bottom layer is the blue cold water and the top layer is the warm red water. Do you see that? And that's pretty much what happens in the ocean with water cycling. The cold water goes to the bottom of the ocean and then gets mixed in the middle in the thermocline, which is the middle of the ocean. So what did we see in this experiment? We saw that as we added the drops, the blue drops, to the cold water side, those slowly pushed their way under the warm water, red dye side, and then slowly circulated. This is what happens in the deep water ocean as well, as this chart will show you. Cold water goes to the bottom of the ocean and slowly gets churned up by the warm water, creating the currents in the ocean, which mixes all the water. It's very important to the ocean currents.
In this next experiment, we're going to investigate the density of salt water compared to that of fresh water. What we're going to do is we're going to take one container of fresh water, place an item in it, and see what it does, and then take another container filled with salt water and baking soda and see what the object does there. And I think we're going to discover that there is a difference in the density of both of these items.
Okay, my assistant Timmy will now place the object that we have chosen into the regular water without salt. Okay, my assistant Timothy will place it gently into the water, the object gently into water, and see if it floats or sinks. You ready? Go ahead. My assistant Timmy will now place the object in the regular water. As you can see, it went to the bottom. Okay, now my assistant Eleanor is going to place the object in the tank with the salt water. Yes?
It floats.
Yeah, it does float. So as you can see, there's more buoyancy in the one that has salt in it. Even though we probably didn't have enough salt in it, so we had to pick this object. Salinity levels are important for two reasons. First, along with temperature, they directly affect seawater density. Salt water is heavier and denser than fresh water.
In this map, you can see saltwater salinity of the oceans of the Earth. The red areas are where it's more salty, and the light blue areas are where it's less salty. This all helps drive the currents of the ocean.
Temperature and salinity both affect the density of seawater, resulting in water moving up or down through the ocean layers and moving as currents around the oceans.
This is a map from NASA that shows the currents of the oceans of the world. The blue is the sub-level cold flow of water, and the red is the surface level warm flow of water. It shows that all the oceans circulate among each other, and everything mixes up.
Ocean currents are one of the factors that can transport and redistribute heat to deeper ocean layers. It can reside in this deep reservoir for centuries, further stabilizing the Earth's climate and slowing the effects of climate change. Right, Eleanor?
Wait, is that?
Thank you, kids, for watching today. Thank you, my assistants, Eleanor and Timothy. And we'll see you next time on Eric's Science Quest. Bye-bye.
Da-da-da.